to today's class. First, before we move into what we have today, I want to know if anyone has questions from our previous class. So maybe we can do a mini recap before we go into the business for today. Does anyone have any questions from the previous class? All right, I think that no, everyone is okay. Okay, so today will be a hands-on session. We are going to be building a basic ERC20 token with using OpenZebelin. We're going to be using the ERC20 token from OpenZebelin to create a basic ERC20 contract. So I'm going to share my screen, and if you are following along with your laptop, you can code along with me so that you can get the muscle memory and see how it all works. So give me a minute to share my screen. Okay. Yeah. Okay, can we see my screen? Okay. So before we start, you will need to have Scarb installed. Scarb is a package manager for Cairo. I believe your past instructors would have guided you through the installation processes, so we won't be covering that in this class. I will just be creating a new Scarb project and going straight into the business of today. So, so for today's class, you can just create a new folder in your home directory. We're going to, let's just name it token cell. So now we are in the folder we just created. Now to create a new Scarb project, we are going to run Scarb init. No, sorry, just Scarb init without a flag. And let's press enter to choose. Don't mind this error we're getting here. I think it's because of the latest version of Scarb, but our package has been created, and you can see we have an SRC folder and a scarb.toml file. So please, as we follow along, if anyone has any questions, feel free to call my attention. Someone is okay. Pascal, go ahead, please.
Okay, I'm sorry, can you hear me?
Yeah, I can hear you.
Okay, I was asking if it's not SNForge in it.
Oh no, SNForge is used for testing, not for creating managing projects. The correct command is scarb init.
Okay.
We use SNForge in our next class to test our Cairo the components we create. But for this class, just the command to create a Scarb project is scarb init.
Oh,
Yeah.
okay, sir. Thank
Yeah.
you.
Okay. So you can open the folder I just created. Mhm. Can you still see my screen? Excuse me. Can you guys still see my screen? Hello, is anyone there?
Yes, I can see your screen.
All right, that's good. Yeah, I changed the margins. So now, since we are going to be using a component from OpenZebelin, we need to include it in our. If you can open your scarb.toml file, and your scarb.toml file contains details about your project. So any dependencies, configuration you want to do, you do them in your scarb.toml file. So we need to add the OpenZebelin dependency here. So I'm going to grab that real quick. Okay. So as of now, I think the latest version of OpenZebelin is 0.17.0. So now that we have done that, we can go into our SRC folder, open our lib.cairo. This is created by default. We don't need this. We are going to create another folder. Let's call it token sale. And inside the token sale, we are going to have the token sale.cairo. Right. This is going to be our contract where we are going to be importing our ERC20 token into. So let's include it in our lib.cairo. We can come here and say mode token sale. Let's make this public. Oh. Okay, so what I'm doing here is okay, someone is raising a hand. So, okay, Favor, please go ahead.
Yeah, good evening, boss.
Good evening.
Please, can you increase the
Okay, my
the
phone size. Sorry.
secondly, yeah, I don't know. I don't want to drag you guys back, but just can you run through it from the creation of the file again?
Okay.
Okay, can you run through it again?
Okay, to excuse me, to create a new Scarb project, just anywhere in your terminal, mostly in your home screen, you can just let me not use this terminal. Let me open a new one. You can just go to your home directory, make a new folder, and just give it any name you want. What you call this new folder. Then you cd into that folder. Okay, now that you are in the folder, you can just run those commands, scarb init, and hit enter, and automatically it will create a new Scarb project for you. Then you can open the project and follow up from where we are. Do you get it? Favor?
Yes, thank you. Thank you.
All right. All right. Mhm. Okay, so let's move ahead. So what I did here, I made this file here, which will be our contract file, part of the, I included it in the package. If you create any Cairo file, any file you want to be part of your Scarb project, you have to include it in your lib.cairo. And every Scarb project must contain one lib.cairo. And the way you do it is, this mod is this folder here. You can have nested folders, and if you have nested folders, you have nested declarations here as well. And the online tool pub mod token cell is the actual file I want to include in our package. So after doing this, we can go to our this thing and start writing our contract. And the first thing to do is to use the Starknet contract attribute, and we can call it pub. So should be resolving. Sometimes Scarb takes time. Sorry guys, please give me a minute. I need to take it.
And while he's trying to sort that, I'm also dropping the link to the slides from the last class. The slides and the GitHub repo. Slides and the GitHub repo. So you can check it on the announcements section of the WhatsApp group. So if you have not gotten access to it, you can go over it now. So you can actually practicalize. The best way to learn is by practicalizing. And also to announce, if you have not done the assignment of last week, I mean, you are moving literally nowhere. You think you know, but you by not practicing, you don't know, right? So make sure you do your assignment. I'm opening the form for one more day for the benefit of 28 of you in class right now. So if you have not submitted, I think just 7 people submitted the assignment. So if you have not done it, it's very important that you do it. Doing your weekly assignment is what ensures that you actually know what you are doing. So if you have not done it, you have from this night to tomorrow night. By next class, the form is going to be closed. So do not progress in this class without doing the assignment for the week, especially last week's one, that you actually write the Cairo code and deploy contract. So if you have not done it, go ahead and do it. Else you're just learning without practicalizing. Emmanuel, if you're back, you can go on.
All right, okay. Sorry guys for the interruption. So, go forward.
Sorry, Manuel. Sorry, Manuel. Yeah.
Yeah.
I just go here and then basically this token sale folder, this subfolder here. I can't
Yeah.
find it. How do you get to it again?
Yeah, you have to create it. I created it. You have to create it.
Oh, all right.
Yeah. Yeah.
Manually or through the terminal?
Whichever you prefer. It doesn't
All right.
really matter. Yeah. Mhm. Okay, so before we start writing our contract, we need to define an interface for it. So let's create another Scarb is resolving. Give me a minute, please. Scarb sometimes can be slow. Let's wait for it to load.
Kevin, are you here? Okay.
Can we see my screen now? Okay, it's fine. Can we see my screen? All right, let's move on. So let's define our interface for our contracts. Let's create a new code interface. Sale.Cairo as well. We also need to include it in our lib.cairo file. Interface. Okay. So now to define our interface. Okay, so we're using
Okay.
okay. Yeah, go ahead, please.
I was thinking, why don't we just add the folder at the lib.cairo file than adding all the different contracts differently?
Okay, if you choose to do it like that, fine. But I'm just doing it like this because I'm used to doing it like this because I work mostly with larger code bases, and with larger code bases, it's better to put things in different folders just not to get things all messed up. For if you are working with a smaller code base, okay, yeah, if creating the files in the same directory as the lib.cairo file won't matter. But this is just generally a better practice. That's why I'm taking my time to do it like this. Yeah. Does that answer your question? Okay.
Yeah, thank you.
Yeah. Okay, let's move on here. So now to create our interface, we are going to use the Starknet interface attribute. We define our interface with the trait keyword. And we're going to name it iToken cell. It's going to be generic over T contract state. So now, for now, we are just going to be having one function, and that function will be to mint, and that will be it will be a state changing function. So we are passing it as a reference. We are passing self as a reference to contract state, and it doesn't return anything. So yeah, and we're also going to have amount, which is going to be of type 2 U into 56. Why is this? Okay. Okay, we're good to go. So we can bring that now into. Is someone raising a hand? Okay. We can bring that now into our contract module. Use token. I think token sale is the name of our. Yeah. Token sale here is the name of our package, and inside that package we have our interface folder. Inside the interface folder we have token sale, which is the contract file, and inside that we have let's wait for it to resolve. It's supposed to be I token sale, since it's taking time. I token sale. Scarb is still under development, so you have to be patient when using it. So after that, now we want to bring the component we'll be using, which is the ERC20 component, into scope. So we can do that by importing it from OpenZebelin. Let's eliminate these errors by defining our storage variables. Let's define a storage variable for the contract first.
Hello, sir. Please, can you zoom in a little bit?
Okay, so is it good?
Yes, yes.
Okay. Storage. This public. We're going to define our event event, and we are going to derive some trait as well. This is going to be what else? Let's give Scarb some time to resolve.
Sir.
Okay. Go ahead.
Please check your spelling of storage. Just change the R and O.
Oh yeah, thank you.
You're shocked.
Sometimes you have to close the project and open it again for Scarb to resolve. But I don't want to do that since Sharing my screen already. Let's just let's just move ahead. So now we need to import our ERC20 token component from OpenZebelin. I believe I got the spelling correct. Yeah. That will be from token ERC20. ERC. Yes. Point this Scarb is just unknown. It's one of the issues developing with Scarb. It's quite slow.
Hello, sir. Can you just zoom out a bit?
Okay, zoom out. Is this okay? Is this okay?
It's okay,
I
sir.
think, yeah, I think I have to. It's taking too long, so I
You
think
can
I have.
you can restart your vscode.
Yeah, I have to restart it at this point. Okay. Can we all see my screen? Yes. So we need to import one more implementation from. Yep, this is it. So the next thing after bringing our component into scope, we're going to declare our component with the component macro. The path is going to be ERC20 components. The storage is going to be ERC20. The event, we can name it ERC20 event. Okay. Now we can add the storage to our storage struct by using the sub storage attribute. Sub storage v0. We are going to give it call it ERC20. ERC20. This component. So by doing this, we are storing this component in the contract state. So this ERC20 storage variable basically holds the ERC20 component we just declared on line 6. After that, we can declare the event for that will get emitted anytime we ERC. Okay. Olafemi, please go ahead.
Hi. I wanted to ask what the flat tag does. I read it in the docs, but I didn't really understand.
Okay, it's I don't think you need to worry about what it does. You just need to know that whenever you are importing a component and you want to add it to the event enum, you always use the flat attribute before the event, just like we're using the sub storage here. This is telling the compiler that this is a component we are trying to store in the storage of our contract, which is token sale here. So in the case of events, we use the flat attribute. Can we move forward? Okay, thank you. So we need to implement our. So far so good. We just declared our component, but we need to, before we can use it in our contract, we need to implement it. And to do that, we are going to start by using the ABI. ABI, okay. ABI, yeah, embed. So it's 0, yeah. Events, ERC20. ERC20 component. The implementation we want. Which one do we want? Yeah, this is the one we want. This is this one. Yes. Let me grab it from the documentation real quick. So this is the implementation of the ERC20 token component from OpenZebelin. In this case, we are bringing in the mixing implementation, which should serve for the purpose we want to use it for. And we are also bringing in the internal implementation so that we can call the initializer, which is an internal implementation on the ERC20 component. So after, just don't worry, Scarb will resolve. Forget about the errors for now. Yes. I think I'm missing. Okay, yeah. So now we can create our constructor for our contract. Constructor function. Remember, I said in the last class the constructor gets called only once. When the contract is deployed. Contracts. So now we want to the initializer function from for the ERC20 components expects a name and a. Let me share my. Let me share the documentation. Let me start sharing this. Can we see my screen? Okay. So to initialize our ERC20 component, we need a name. We need to pass a name and symbol of our token to the ERC20 initializer. So let's do that in. So we are going to let name equals. This should be a byte array. Let's call it token. Just give it the name of our contract. Let's see that. TS. Okay, now we can call the initializer function. We do that by We pass in the name and symbol. Now, when this contract gets deployed, our ERC20 token will be initialized with this name and this symbol. We can change it, you can make it more flexible by passing in the parameters in the function, but for this. But I think this will serve for the purpose of this class. And on what's going on line 30 here, since we have declared the ERC20 component in our contract storage, whenever we want to interact with our components, we do it by calling it on the self. Remember, we are passing in self here as a reference because this is a state changing function. This is going to change the state of our contract. So you're passing in self, the ERC20, and from ERC20, we have this initializer function, which is made available because of this internal implementation on line 10. My Scarb is not resolving. If not, if I comment this out, if I were to comment this out and Scarb was resolving, I'll get an error here telling me there's no implementation found for initializer in the current context. So whenever you want to call the initializer from a component, most times the initializer is an internal function. You have to bring in the internal implementation of that component. So now we want to move to the actual implementation of our contract, and we are going to do that in our implementation block. We need to grab this API embed. Implement token cell of. Now we are implementing it for this trait we defined here, iToken cell, and we already imported iToken cell here. So we're going to say of iToken cell generic open state. Okay, please. Who's raising a hand? Was someone raising a hand? Okay. Okay, we only have one function here, which is a main function. So we are going to grab this real quick. Now, we want, anytime this function is called, new tokens are going to be minted. So we want to grab the caller, which is the caller, who is in the caller, the person, which is the person calling this function. We can use that, do that by using the get caller address from Starknet, and we will need to import it here. Use for Starknet get caller address. This will return the address of the person calling this function. Now we want to assert that the person calling this function is not address 0. We're going to do that by assert caller is known 0. And if that's the case, we're going to revert with an error 0 caller address. Okay. Now, if the check on line 38 is passed, we want to mint new tokens to this caller. To do that, we are going to say use the ERC20 token component dot mint, and the mint takes in an address, which is the recipient, which in this case will be caller, and the amount we want to mint, which is the amount we are passing here. So that should be it. Scarb doesn't want to resolve. Okay. Someone raising a hand? Was someone raising a hand? Okay. Thank you. Okay, Pascal, please go ahead.
Please, you can remove the T contract state, the T in the T contract state in the parameters of that FM mint in your ABI embedded VNode. Just where your cursor is.
Sorry, thanks for that. Okay. I think we should be good to go. We can test our contract, but the problem is Scarb isn't resolving.
Check if you can restart your vscode.
Let me restart it. Okay. Can you see my screen now? Can you guys see my screen? All right. So now we have an error on line 38, and what is it saying? Method is not found. Okay, we are missing a trait which I forgot to import. Use for traits. Let's see. This will bring this function into context. Error should be oh, missed say config column. Okay. Yeah, we are okay, so now we can deploy our contract and test it, but before that, there's one more thing we need to add to our Scarb.toml. So we need to add the target Starknet contract configuration. After that, I need to also to deploy. I need to create a 100 file so that I can Just using my default profile. So we're going to be using SNCast as we did in our last class. Usually when you want to deploy your contract, you need to specify the account you want to be using. And this account is coming from this directory here. I can open it real quick. Code. So that you can see. Yeah. So this is an account contract, a contract account that you can use to deploy other contracts. So this is beyond the scope of this lesson. So I'm just showing you guys so that you know what I'm doing. So whenever you want to deploy your contract, you have to create a contract account and fund it with Stark tokens and Ethereum tokens. In your snfoundry.toml file here, you can specify which of the contract accounts you want to use. In this case, I'm using my Sepolia account, which is this one here. And you can see it has address, class hash, and stuff. Other stuff a basic contract will have. So now I can use this contract to deploy the contract I just created. We do that with SNCast. Now profile. I'm going to pass in this profile here, Sepolia account. Now I have to declare the contract first. The command will be declare. Pass in the contract name, which is this token cell.cairo. Let's give it some time to compile. Are we following along? Okay. Second folder. Let me correct this typo. Let me correct this typo I made here. It's supposed to be just implementation. Yeah. I think I will have to close. I'll open it in a separate terminal to compile it. Let me open a separate terminal. The build it first of all. So, please go ahead. Yeah, it's not just WSL, it's Scarb package manager as a whole is slow. Although with the latest version, they made it better, but still nowhere where we want it to be. It's still work in progress. So. Okay. So we can declare our this thing now. File device account. Okay, successful, and we have the class hash now. We can use the class hash to deploy the contract. Okay. Let's copy our contract address and go to Starknet. Yeah. Let's give it time to index. Sometimes it takes time. Okay, this is our contract now. We can come here. We can read the contract now. Now, this function here, remember in the traits we implement, we defined for the contract, we just had one function, which was a write function called mint. But you might be wondering where these functions are coming from: total supply, balance of allowance, name, and stuff. These are all coming from the ERC20 token component we embedded in our contract. Remember in our last class, I said components can't be deployed on their own. They have to be embedded in a contract. And when they are embedded in a contract, their functions, that's the external functions you expose from that component, becomes part of the contract you are embedding it into. So now automatically you can call these functions on this contract because you embedded the ERC20 token component. And for now, if we query the total supply, we get 0 because we have not minted any tokens yet. If I am to check my balance, let me get my contract address real quick. If I'm to check my balance, yeah, we should get 0. The name should be token sale boy. The format is in hexadecimal, so this should be. Let's use nope, I shouldn't have done that. Let's use Voyager. I think Voyager will allow us to view the text. Switch to simple. Yeah. Is this the correct one? Shouldn't have that tokens. Yeah, okay. This is the correct one. So if we come down here and change this to text and query it, yeah. You see, this is the name. So this is proof that our initializer function we called in the constructor got executed. If we do the same for symbol, yeah, we are getting TX. The decimals by default is 18. Yep, for ERC20 token is 18. Total supply, this is just common case, is the same as this, and balance of. So we can write the contract now. For that, I have to connect Bravos. And now this is the means function we define in our implementation block. Now, let's say I want to mint 1,000 tokens. Now, when you want to mint, let's say one, let me use Stark for example. Now, Stark is an ERC20 token. Because the decimals is 18, Stark has a token decimals of 18, we need to account for the token decimals. So we need to append 18 zeros to make it one Stark. So we're going to count to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now this is equivalent to one Stark. If we are to change this to 2, this is equivalent to 2 Stark. Now we can transact. Yep. Now we can sign the transaction. Yeah. Let's wait for the transaction to be executed. Okay, completed. Now we can go back to read contract and check if the total supply now should have changed because we just minted tokens. You can see the total supply now is now 2. We can check the balance of we can check my balance, paste in my address here. I should get yeah, this. Okay, can someone paste in their address so that I can send some tokens to them? Please, someone paste your address in the chat. I didn't say account number, I say address. Why is someone asking Pompey? Okay. Let's go to read contract, right? Contract. Okay, now I can transfer, enter the recipient, and I want to transfer one. And transact. Okay. I've transferred one token to this address. Now I can go back and confirm my balance. The total supply should still remain the same because we didn't mint any new tokens, we just transferred. But now if I query my balance, I should get one. Yeah. So one has been deducted from my balance and added to the contract I just transferred to. If we are to confirm that, yep. And so our contract is working perfectly, just the way we want it. Well, there are some improvements that can be made. Let me close my. Let me open up window. Can you guys see my screen? Okay. Okay, so now we have successfully integrated our ERC20 token into our contract. And this is like the most basic form of ERC20 token integration you can do. But there are some things we can do to improve this contract. For now, this mint function can be called by anyone. Anyone with our contract address can basically call this mint function and get tokens. Most times, that's not what you want. That's where the ownership comes in. We can use the ownable component from OpenZebelin as well to extend this contract and make it more secure by making only the owner of the contract, giving only the owner of the contract privileges to mint. But I won't be doing that. I'll be giving that as an assignment on Friday. That will be, you guys would extend this contract by implementing ownership functionalities on the contract. And if I believe if you are able to do that on your own, then you have a good grasp of how components work. Yeah. So far so good. Does anyone have any question? If you have questions from our previous class and this class, feel free to ask.
Oh, okay.
Yeah.
Good evening, sir.
Yeah, good evening, Gideon.
All right, thank you for the class today.
Yeah.
So I wanted to ask, I was looking at this dispatchers and then now I'm looking at components. So I don't know, is there any relationship between the two? Like when it comes to probably cross-contract interaction. So I don't know like which one is useful, where and all of that. So I don't know if you can give me some clarity. I would really appreciate.
Okay, dispatcher, how do I explain this? Dispatcher is used to interact with a contract from another contract. Let's say we have built our contract now, and our contract is token sale. Let's say we have another contract in our folder here, in which we want to use token sale. We want to use maybe a function from token sale. We want to use this mint function. Yeah. It's similar to component, but it's quite different. We can do something like this to import it in. If we were in another contract, we can say use token sale. I wanted to resolve. Okay, yep. Token sale. interface. The dispatcher always comes from the interface. Token cell. Inside the token cell, we will have the I want it to resolve so you can say, okay, yeah, great. So now the first one here is the interface itself. Now this is the dispatcher. Now with this dispatcher, you can call the functions on this contract, the external functions on this contract. You to import this, and whenever you're importing the dispatcher, you also import the dispatcher trait as well. So let's say I import this here. I will also need to import the dispatcher traits. I open. Yep. So I need to trait. Yeah. So for example, now if I want to use this, let's say hypothetically I'm in another contract and I want to use this a function from this contract, I'm going to call that function using the dispatcher. So the way it works is I can, let's say in my mint function, I can come down here and say let token cell dispatcher equals to this. Now I need to pass in the contract address. Every dispatcher needs a contract address. Let me just pass in this for example's sake. Now with this dispatcher, I have access to all the internal functions on this token cell contract. I don't know if you're following.
Yes, sir.
So now to call this mint function, as if we were in another contract, I can just simply say token cell dispatcher dot mint. Yep, and I can pass in amount. Yeah, so this is how you use dispatchers. They are used to interact with a contract from another contract, and it's mostly in the yeah. You can import from, you can components too in a way have their own dispatchers. For example, if I want to, someone raising a hand. Okay, go ahead, please.
On line 44, like what contract address are we exactly passing to that I token says dispatcher?
Okay.
Like what contract?
That's a very good question. So now if we want to, there's a function called get contract address from Starknet, similar to get caller address. Get caller address returns the caller, the address of the person calling the function. But get caller address returns the contract address of the contract itself. Are you following? So we can get the contract address. The token sale dispatcher expects the contract address of token sale of this contract. Yeah, this. So usually before you use the dispatcher, you have to have deployed the contract already. Are you following?
Yes, sir.
Okay, yeah, so before you can use dispatcher, you have to have deployed the contract already for you to get the contract address. Now that contract address is what you are going to pass into this dispatcher, in this case, token sale dispatcher. So that's the difference between dispatchers and components. Components don't need to be deployed. Instances where you use choose to use component over dispatcher if you have like a unit of code, like for example, ERC20, the ERC20 token component now is managing everything that has to do with creating ERC20 tokens and transferring tokens from one user to another. It's always a good idea to bundle all of that, abstract that into a component so that you can use that whenever you want to. But let's say we don't want to create a component for that, and for that, and we want to interact with our mint component, our mint function here from another contract. We can just import the dispatcher using this, like we did here on line 3. And by importing this and having deployed our token sale contract, we can just pass in the contract address to the dispatcher, and automatically we have access to the external functions on that contract. So if we are to define another function here, it will be part of the dispatcher. Dispatcher is just a way of interacting with a contract from another contract. I don't know if you.
Yes, right. Thank you so much. The explanation is clear.
Okay, yeah. Okay. That's good. Does anyone have any more questions? Okay, please go ahead. So Madina,
Yeah. Thank you for the classes so far. I noticed something. You used implementation twice in these contracts. Like I don't like it's a bit confusing. Can you just explain it to me?
Okay. The implementation on line 12 and 13 are for the ERC20 token component. And if let's go to the ERC20 token file so that I can show you the main file from Opens the Berlin, so that I can show you why it's necessary to implement. Okay. So now this is the ERC20 token component. Now this is an implementation for the camel only implementation. Camel case is just you know camel case now. Total supply, instead of using underscores, we are using like capital after each word. So if you want to use the camel case implementation, this is what you're going to use. In our case, we are bringing in the mixing implementation. I can copy that and find it in this file. Okay, yeah, this is the implementation we brought in. We don't want every implementation from the ERC20 token file component because there are several implementations. We just want the one we want to use, which is the ERC20 mixing implementation, and it has all these functions here. So if you go back to our contract on StackScan, you'll see that those functions we can call from there are the functions implemented here. Yeah. And this is the end of this implementation. And we are also implementing the internal implementation. If we scroll down to the bottom, we're going to find that okay, yeah, this is the internal implementation for the ERC20 token component. And you can see the initializer is coming from the internal implementation. And the initializer is just setting the name and the symbol. If I were to go back and comment out line 13 and wait for Scarb to resolve, you can see automatically I'm getting an error here. Method initializer not found on type. That's because there's no implementation in this contract for the ERC20 token internal implementation. So whenever you want to use a particular function from a component, you need to just check which implementation has that function you want to use. Where is it? And implement it in your contract. In this case, we want to use the internal implementation. So we just implement it here on line 13. The same thing is going on line 12. And on line 37, this is the actual implementation for our own contract. Yeah, and we are implementing it for the interface we defined here. Where is it? Yeah, here. And we just have one function, which is a mint function to mint new tokens to users. And this is the syntax: implement token sale, the name of the implementation. It can be anything, doesn't have to be the same name as this thing, but it's usually good practice to keep it as the same name to avoid confusion. And we are implementing it for the interface, and it's generic over contract state. And once you have that, you must implement all functions in this interface. If not, your code won't compile. And here we are this is the implementation for mint. And mint is just essentially minting new tokens to users. So that's just the use of implementation. Implementation is used to how do I put it? Should I say implement the trait you define for a particular contract? Another key thing to note here is this attribute, the ABI embed v0. If I were to comment this out, the code will still compile, but the thing is, this implementation now won't be part of the contract ABI. That means I can't interact with this function here from outside the contract. So if I deploy this, if I comment this out now, this line 36, and deploy this contract, I won't be able to call mint because I didn't specify, I didn't state that I want this implementation to be embedded in the contract ABI. So whenever you want to make your functions external, you use this attribute here, ABI embed 0. Notice we are doing the same for this one, ERC20 mix-in implementation. This attribute doesn't apply for line 13. If I wanted it to apply for line 13, I will do the same thing here, like this. But this is an internal implementation. We don't want that. In fact, this will throw an error because we shouldn't be able to do that. And this also is exposing the external functions from the ERC20 token components, like, did I close that? Yeah, I closed it. Like the transfer, the balance of and stuff, etc. So that's basically what the implementation is for. In this case, in the case of components, you are bringing in the particular implementation you want to use from that component, and for line 37, you are implementing the actual contract. Someone was using. Who was raising a hand? Sorry, I was not on the Google Meet screen. Was someone raising a hand? Okay. Sorry, who asked the question again? Gideon, was it you?
It was me. I understand now, sir. Thank
Okay,
you
you
very
understand.
much.
Okay. Any more questions? Okay, someone asked what's the difference between initializer and constructor. Constructor is a function that gets called only once, and that's when the contract is being deployed. Any logic you have here in a constructor gets executed when the contract is deployed. But it's not the same. Initializer is just a function like any other function. But the name is kind of self-explanatory, and we mostly use initializer in components. Now, in the case of this ERC20 component, we want to initialize the component, and we want to set the name and the symbol for that particular component. And since this is something we want to do only once, it's a good idea to call the initializer of a component in the constructor of your contract. So after that, there's no way to change the name and the symbol anymore. You can do that, but you have to expose the internal implementation, which in most cases you don't want, because the function is internal. It should be only be able to call from inside the component. And that's not what you don't want users calling your internal implementation. So that's just the difference between constructors and initializer. Constructor gets called only once. Initializer is just a function you can call in your constructor to initialize your component. You can call it wherever you want, but it's just a good idea to call it in your constructor. I don't know if that answered your question. John Williams, have I answered your question? Okay, yeah, thank you. Does anyone have any more questions? So far, so good. Are we understanding? Is there anything you need me to? Okay, Wisdom, please go ahead. Wisdom, do you have a question? Okay. I guess we don't have any more questions. So we can call it a day here, and okay, thank you, Wisdom. In our next class, we are going to be testing our component. And after that, we should have covered like 70, 80%. Okay, Oluwafemi, please go on. Go ahead.
I just wanted to ask if you could provide the link to the repo maybe later when you're free, so we'll be able to look through the code. Thank you.
Sure, I'll do that right away. Let's see.
Hello, sir. Can you hear me?
Yeah, I can hear you. I'm trying to upload it to GitHub.
Sorry, I have a question. The question might seem a bit odd, like off, but I'll still ask because I just need to clarify something here. Like, what's the whole idea of this token sale contract? Like, what is it all about? What are we trying to achieve here? Because me, I'm just confused somehow because I'm trying to wrap my head around the whole thing because I need to actually build the muscles to understand the whole implementation and functions going on.
Okay. The whole idea is just to explain how components work and how to use them in your smart contracts. Most times when you are writing smart contracts, you'll find yourself wanting to use components. One of the most commonly used components is the ERC20 token components, which we use today in our contract. So the ERC20 token component allows you to create an ERC20 token component which complies with the ERC20 token standard, and you have your functions like mint, which allows you to mint tokens, transfer, which allows you to transfer tokens from one user to another. You also have approve, which you can use to approve another person to manage your tokens. You have transfer from and other functions as well. The native token on Starknet, on the Starknet network, is Stark, and Stark is an ERC20 token component, is an ERC20 token. And you all have all these functionalities on Stark as well. So the whole idea of the token contract is just to show you guys how to use an ERC20 token component in your contract. And the assignment I'll be giving you guys on Friday, which is to extend the contract by adding ownership functionalities. You will get to bring in the ownership component from OpenZebelin. I'm going to share the link to OpenZebelin documentation so that you can refer to it if you have any difficulties. And as well, you can always reach out to me. I'm always glad to help. So I hope that answers your question.
Yes, thank you.
Okay. Okay, I'm dropping the link to the GitHub repo for you to take a look. And I also dropped the link to OpenZebelin documentation. Yeah, that's the link to OpenZebelin's Cairo contract library. You can refer to that. You can the ownership component you'll be using in the assignments. You can find it there on OpenZebelin. So, does anyone have any more questions? Excuse me. Okay, I guess we can call it a day here. Thank you guys for your presence, and thank you guys for attending. I'll see you guys on Friday in the next class. Yeah. Good night.